This is a video from section 10.2. The directions say to find the area enclosed by the given parametric curve and the y-axis. So we need the following formula. Area is the integral from c to d of x dy. And we're going to take this integral here and transform it into an integral in terms of t. So let's go ahead and take a look at the following example. Suppose we're given the following parametric equations. X equals sine squared t and y equals cosine of t. So let's draw a picture. So we have the x and y axis, and we have a curve, and we're trying to find the area of this shaded region right here. Now, remember here that area is the integral from c to d of x dy. Now, x is sine squared t. Now, dy, I could figure out up here, is negative sine t dt. So I'm going to multiply sine squared t times negative sine t, and I'm integrating with respect to t. Now, we need to figure out our limits. How do we do that? Well, these limits, c and d, are in terms of y, but we need these limits in terms of t. So what do? We're going to set x equal to 0. But that says sine squared t equals 0. And so that says t is 0 or t equals pi. Okay? Now, why didn't I choose 2 pi? Because when t is equal to 2 pi, we have x equals 0 and cosine of 2 pi equals 1, so y would be 1, which means you're going to be dealing with this point up here. And if t is equal to 0, x is equal to 0, and cosine of 0 is 1, and so y equals 1, so you end up getting the same point again. But when you choose t equal to pi, sine of pi is 0, so x is 0, right? And then cosine of pi is negative 1, and so y is equal to negative 1, which would put you down there. And so that's why you would end up getting t equals 0 or t equal to 2 pi. The question is, which one's the lower limit? Well, when t equals pi, I'm going to solve for y, and I'm going to get y equals negative 1. And remember, x equals 0 is the whole time. So that's going to correspond to this point here, and that's my lower limit. And so we know my lower limit is pi. When t is equal to 0, cosine of 0 is 1, so y equals 1. And so my upper limit will happen to be 0. And so you're going to integrate from pi to 0 of sine squared t times negative sine t dt. But remember that sine squared t is 1 minus cosine squared t. So the area is the integral from pi to 0 of 1 minus cosine squared t times negative sine t dt. And this is a straight u substitution. So I'm going to let u be cosine of t. du is negative sine t dt. When t equals pi, cosine of pi is -1, so u equals -1. So I'm plugging in up here. When t equals 0, cosine of 0 is 1, so u equals 1. And so therefore, area is the integral from -1 to 1 of 1 minus u squared du. And so this is u minus 1/3 u to the third from -1 to 1. And so when I plug in 1 for u, I get 1 minus 1/3. And I'm going to subtract, by the way. When I plug -1 in for u, I get -1 plus 1/3. And so this is 2/3 minus -2/3. And so the answer to example 1 is 4/3. And with that in mind, let's take a look at example 2. Suppose I'm given the parametric equations x equals t squared minus 2t and y equals the square root of t. So I want to look at the region that I'm going to, the shaded region that I'm going to find the area of. So here we have x and y. The curve is going to look something like this. And I'm going to find the area of the shaded region in blue. And so in this problem, it's a slight twist on the formula that I provided at the beginning of this video. Now, notice that you're finding the area of a region on the left side of the y-axis. And so it turns out the area is going to be the integral from c to d. Instead of x, it's going to be -x dy. Okay, remember that you want the area to be non-negative. Okay? And so you can think about it this way. If x is less than or equal to 0, then -x is greater than or equal to 0. And so if I integrate -x dy, that's going to produce a positive result, especially going from c to d. Okay, I hope that makes sense. Now, if x is t squared minus 2t, then -x is going to be 2t minus t squared. So we're going to integrate 2t minus t squared. But remember, y equals the square root of t. So dy is 1 over 2 square root of t dt. So I'm going to replace dy with 1 over 2 square root of t dt. Now, we need to find our limits in terms of t. So once again, I'm going to set x to 0. So t squared minus 2t equals 0. So t is 0 or t is 2. So you notice when t is 0, y is 0, right? So that's down here. That's the ordered pair 0, 0. When t is 2, x is 0, and then y is equal to the square root of 2, which would correspond to this point up here. So my lower limit is going to be 0. My upper limit is going to be 2, like so. So let's rewrite that. The area is the integral from 0 to 2 of 1 over 2 square root of t times 2t minus t squared. dt. So I'm going to distribute the 1 over 2 square root of t in. So I'm going to integrate from 0 to 2 of, it looks like t to the 1/2, or square root of t, minus 1/2 t to the 3/2 dt. So this is going to be 2/3 t to the 3/2. That's the function whose derivative is t to the 1/2. Minus 1/2 times. If I take 3/2 and add 1, I get 5/2. So this is 2/5 t to the 5/2, right? 2/5 t to the 5/2 is the function whose derivative is t to the 3/2. And I'm going to evaluate from 0 up to 2. So I'm going to replace t with 2. And I get 2/3 times 2 to the 3/2. And 2's cancel here. So I get 1/5 times, again, replace t with 2, and I get 2 to the 5/2. If I replace t with 0, it's 0. So I'm just subtracting off 0. Now, this is 2/3 times 2 square root of 2 minus 1/5 times, now 2 to the 5/2 is, it looks like that's going to be 4 times the square root of 2. Like so. So this is 4/3 square root of 2 minus 4/5 square root of 2. And so it looks like it's, let's see, so that's going to be 20 minus 12, which is 8. So it looks like this is going to be 8/15 square root of 2. And that'll conclude this video for section 10.2. We looked at 2 examples of finding the area enclosed by the given parametric curve and the y-axis this time. Okay, thank you.